Simplifying rational expressions. Now, a rational expression is simply nothing more than a fraction. You have to understand that when we are looking at things like what we see up here, we got the 2x squared plus 4x minus 4, or x plus 3. These are actually representing a value. Number on top and number on the bottom. Value on the top, value on the bottom. And when we're looking at these things, they behave exactly the same way that fractions did back when you were in elementary. Same rules apply. We're working with. Now, we're adding on one more thing that you have to think about, and that is division by zero. You have to have it in your mind, and we've talked about this before. Division by zero is undefined. We cannot divide by zero. So that means whenever we have a fraction, the denominator cannot be zero. So if I'm looking at this one here, and they give us this x plus 3 on the bottom, what number can't I have x be? Well, I can't have x be equal to negative 3. Why? Because it makes the value unknown. You can't do it. It's just not there. Gone. That doesn't mean you can't have 0 on the top. That actually has a certain thing that we take a look at later. But the denominator, whenever we have something like this, we must take a look at it and make sure that it does not go to 0. So if I look at these two that are down here in the box, I got negative 3x minus 6 over 4. Perfectly legal. Problems. 4x squared plus 16 over x squared plus 1. Perfectly legal. No problems. I can put any number into those that I want. You got to remember that if I got x squared, I put a negative in there, it becomes positive. I put a positive in there, it stays positive. I put 0 in there, well, 0 plus 1 isn't 0. Over here, we have one of those quadratic things. We got the x squared plus 3x plus 2. We know how to factor those things out. I've looked at that already. When I factor them out, I get two answers, negative 1 and negative 2. If I put either one of those answers in there, this thing doesn't work. And these are the things that we are going to take a look at when it comes to the domain that we have to make sure it doesn't go in. Now, the next thing, we have to learn how to simplify these things. That's as simple as it gets, x cubed over 2. This is as simple as it gets, x plus 3 over x plus 4. This is not simple. Now, earlier this year, we've taken a look at how we simplify those things, remember? Down here, this isn't simple because I have x minus 7 on top, x minus 7 on the bottom. Now, I want you to notice that these here are being multiplied. See this x plus 3, x minus 7? There's multiplication going on here. I cannot cancel these x's here and say it's just going to be 3 over 4. It doesn't work that way. And if you think that it does work that way, I can show you how you make, let's see, a 6 over 2 equal 4. Right? Show you. If you have 6 divided by 2, that's supposed to be equal to 3, correct? Well, isn't 6 the same as 2 plus 4 over 2? Can I cancel like that and say it's equal to 4? No, that doesn't work. It doesn't make any sense to us. Because it works over here because 2 times 3 over 2 is equal to 3. So a multiplication we can cancel. That's what we want to look for to make it work. We cannot cancel when there's an addition going on. So when I look at this one here, I got x plus 3 times x minus 7 over x minus 7. These x minus 7s can get canceled out. Just be left with x plus 3. So that whole idea, same thing on the top, same thing on the bottom. We can cancel. Okay. This is the rule that we've used before. quotient of Prowler's property. Now we also kind of looked at this, that if we had A over M over A over N, I could bring this up and now it would become A to the what? Well, it's going to be an N up there, but it's going to be that negative. Remember, we can move it from bottom to the top and change the sign. So, all of these little things that we have to keep in mind. So, I'm going to go through these, and I'm going to go through these nice and slow. And if you have questions, if you see something, please let me know. Now, they want to go through and identify, any excluded values. What can't I have? Well, it looks like I can't have 0. That would be a bad thing, right? Oh, yeah, I just noticed that here. Every day. Now, if I look at this one here, I got 2m cubed over m squared. Could I move this up here and call it m to the negative 2? Would that be legal? Yes or no? Why? Why ain't that legal? Well, is it the same m? I mean, if I go back here to this rule here, a and a here, m and n, those can be different as long as the base is the same, we're okay. M was the same, so I get to move that up there, and it works perfectly well. So, okay. So if I go and work this out, would I end up with just simply 2m? Now, if I look at this, I could plug a 0 into this and it would be perfectly fine, right? But because the original function was sitting and looking like this, the original expression, I should say, that was what we start with. So m cannot be equal to 0. X cannot be equal to 0. Now, if I simplify this, if I do the same thing that I did here, I could bring this up here, make it x to the negative 7. That leaves me with x to the negative 3 when I combine those together. Now, can I rewrite this as a fraction so that I have a positive exponent? Remember how we do that? We could just say that this is over 1, and now it's going to be 1 over x cubed. So would I want x to be 0 at any one point in time? No. Is this the only way to look at it? No. I suppose if you wanted to, I could have done it this way. That means that I have 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, right? X cancels, X cancels, X cancels, X cancels. How many X's do I got left down here? All the little group tools that you've got, little things that you can remember, ways of doing these things can be used. It's not just one way of doing it. So, yes. Sure. That would have worked just as well. I could have brought that, I could have had x to the 4th over x to the 7th. I could have brought that down here as x to the negative 4, and then add 1 over 3 again. Or x to the 3rd, excuse me. Yeah, same thing. It all depends upon what you see. Now, the reason that you would have probably thought about that is because 7 is bigger than 4, right? Yeah. And you can take the smaller down to the larger, and you're fine. As I just said, more than one way of dealing with this for those who So now, getting up to the good stuff. I need to figure out how to cancel this. Now, we know that we can't cancel, that 8 and that 8 ain't going to work. This is where identifying what can be factored out. Whenever, yes, sir? Yeah, you're getting ahead of me. It's okay. What we want to do is we want to look at whatever we can factor out. If we can go and turn the numerator and denominator into just a group of factors. And what I mean by that is, remember when I was playing with this down here and I rewrote 6 as 2 times 3? If I can break it down so that I know what is being multiplied together, I can then cancel things out. So I look on the top here and I see that I got a 4x and I've got an 8. Is there anything I can factor out of each one of those terms? And it turns out that I can factor out a 4. Now I know you said 2, but I want to factor everything out as much as I can. So that leaves me with x plus 2. Would you agree? Now I want to factor out an 8. Why? Because I'm left with that, and 8 comes out of 16, so I get x plus 2. Okay? So the first step that I did is I factored out the whole number. Now, do you see some things? Yeah. So if I've got the 4, can I just do this? There it is. So I'm looking at this, and what should I do next? Well, I could cancel. This x plus 2 can wipe out this x plus 2 down here. Why? Multiplication. This 4 and the 8 can cancel out, right? So that would go to a 1, and this would go to a 2. So this works out to simply be 1, 2. But we have to take a look at what can we factor out, and then what can we cancel. Make sense? Questions? Let's try this one. Now, we've always got to use everything in our toolbox to deal with this. I see this b squared. Now, whenever I got a squared term, I always have to go to the quadratics. So, and I look, can I cancel anything out of here? Now, I've got a subtraction there, and I'm thinking, 2 terms, I got something squared, I got difference of squares. That'd be nice. But 3 isn't a perfect square, 27 isn't a perfect square. Can I pull a 3 out of each one of those terms? So I could pull a 3 out here, and I would be left with b squared minus what? 9. Ooh, is 9 a perfect square? So now I can go one more step. I can rewrite this as 3 times b minus 3 and b plus 3. Because isn't that how that factors out? So by going and completely factoring out the top, I'm seeing something now that I might be able to cancel. Because on the bottom here, it's just simply b plus 3. Okay? I got a question. If I want, can I put parentheses around those two to make it look like everything else? Is that legal to do? Is it? Yes, it is. So that means over here I can put in parentheses b plus 3. Can I cancel anything now? Yeah. B plus 3 cancel the b plus 3, and I would have that left over. Now, depending upon what you're working on, what you're doing, you might be able to just leave it like this, or you might see it written out like this. Make sure that you understand that both of those are the same answer. One has the distributive property applied back to it. All depends. You could be working on an ACT test or an Accuplacer test, and this kind of stuff is very much in those type of tests, where you have to deal with these rational expressions. Simplify. You might do it they end up with this answer, you've got that. Make sure that you see it. All right. Questions on this one? Let's try this one. Now, sometimes we're going to end up having to do a sign change. Okay, we kind of looked at this a little bit before. One of the things that I'm going to do is I'm going to rewrite this thing so that I have numbers over numbers and variables over variables. So, my first one here, I've got 6x minus 12, but I'm going to rewrite this as negative 3x plus 6. Does that make sense to you? I've got the x's all lined up, I got the numbers all lined up. It's just something that I like to do. Now, could I factor anything out of the top? I got a 6 in there. So I could factor out that 6, and I would be left with x minus 2. Is there anything I can factor out on the bottom? And now if I were just to factor out a 3, I would be left with a negative x plus 2. You see what's missing? Does this and this look vaguely similar? I got an x and a 2, and I got an x and a 2. I got sign problems. So what I could have done, rather than dividing out by just the plain old 3, I could have factored out a negative 3. If I pull out the negative 3, that leaves me with an x, right? Negative 3 times x gives me that. If I take negative 3 out of a positive 6, that leaves me with a negative 2. Now I've managed to get the exact same thing here, the exact same thing here. So this cancels with this. 3 goes into 6 and I get 2, but I got this negative here, so this is just simply negative 2. That's what it is. But it really comes down to making sure that you can simplify things out. Get the multiplication of factors on top, multiplication of factors on the bottom, cancel what you can. Questions? Concerns? Thoughts? Let's give this a whirl. Now, is that one looking even uglier? Oh yeah. We got ugliness going on here. Okay? This one's going to take even more. We know how to go and factor out quadratics. We've taken a look at them. Now, I look on the top, and I've got a 2, a 4, and a 30. Can I factor out that 2? The answer is yes. Most of the rules that we have make x squared positive. So what I'm going to do here is I am going to factor out a negative 2. What am I left with? Well, then I would be left with x squared plus 2x minus 15. And if you don't know whether you factored that out properly, always go back. Negative 2 times x squared gives me negative 2x squared. Negative 2 multiplied by 2x would give me negative 4x. Negative 2 times negative 15, positive 30. So we got that. Now, what about the denominator? I got a 3, a 21, and a 30. Hey, I can factor a 3 out of all of those, right? So what would I be left with? Well, then I would be left with x squared plus 7x plus 10. Okay. That's step 1. Now, we have to factor these quadratics. So we want to pull out any common value. Now we are going to factor. So we got negative 2, 3. Now we're hoping something's going to cancel on this. I see a 5 and a 10, so it's possible we'll have something. So now we got to go back and use those rules that we have for setting this up. We got an x, we know we got an x. If that's negative, one of these is positive, one of these is negative. Down here, this is positive and that is positive, so I know one of these is positive and the other one is going to be positive. Plus x plus. Okay. So, can you do in your head what factors of 15 have a difference of 2? 3 and 5. Okay, which one has to be positive? 3 or the 5? 5. Because 5, positive 5, negative 3 gives me a positive 2. So that tells me that my 5 is here and my 3 is over here. Okay. What factors of 10 add up to 7? Signs are the same. We got to find the sum. Now, one thing that's kind of helpful here, 5 and a 3. I would like to think that I could cancel one of these up here, right? So if I look at the factors of 10, that one of them is a 5, because 3 isn't a factor of 10, is it? 5 is a factor of 10. 5 times 2 is 10, right? Is 5 plus 2 7? Yes. So I've helped, kind of using what I have here to lead me down the path. So I've got it factored off now. 5 times 2 is 10. 5x plus 2x, 7. 5 times negative 3, negative 15. Positive 5x minus 3x, positive 2. So can I do any canceling? Do I see something that is the same on top and the same on the bottom? That turns out to be right here. The x plus 5 and the x plus 5 cancel. Nothing else is going to cancel. So the answer is going to look like negative 2 x minus 3 times 3 times x plus 2. Yes? Questions? Now, unfortunately, the only way you get good at dealing with these things is practice, 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 and then guess what? More practice. So, now, application, I want to talk about it anyways. Basketball is a sphere, right? Write a simplified rational expression for the volume to surface area ratio of a basketball. And you're kind of going, what? How do I know any of that? Well, in your book, they do provide the formulas for those. But I'm going to give them to you so that you can write them down. So, volume of a sphere is equal to 4/3 pi r cubed. Surface area of a sphere is equal to 4 pi r squared. That's just what those things are. So, whenever they want you to come up with a ratio of something to something, they'll always give you something first, give you something second. First goes on top, second goes on the bottom. So, what goes on top? Well, that would be 4/3 pi r cubed. All over 4 pi r squared. Can I cancel anything? Well, first off, is it all multiplication on the top? Is it all multiplication on the bottom? Yes. So I can cancel this pi with that pi, so we have no more pi. I have 3 r's up here, 2 r's down here, so these two can cancel with 2 of them up here, and I'm left with 1r. So that means that I have 4/3 divided by 4, and there's an r up here. Now, of course, you got to remember how to deal with fractions. So I'm going to put this over 1, multiply by its reciprocal, 4. Can't divide by a fraction, got to multiply by its reciprocal, so that means the 4's cancel out, and I end up with just simply 1/3 r. Okay. It's ugly, but that's the way it is. So now the question comes up here, what is the volume to surface area ratio for a basketball whose diameter is 9? Well, what's the diameter? If the diameter is 9, what's the radius? 4.5. So that means all it do is put in 4.5 and multiply it by 1/3. So what I want you to do is I'm going to start you off with A here, and you're going to go and take a look. Give me a couple of minutes, and I just want you to do A. Here we go. Now, if I look at this, I've got 3p8 over 9p cubed. So 3 of these canceled out with 3 of these up here, so that leaves you with 5. This goes to 1, that goes to 3. How many 3's are in 3? 1. How many 3's are in 9? 3. So that means the answer for this one is going to be p to the 5th over 3. What number could I put in front of that p if I really felt like it? Yeah, it is 1/3 p, but the problem that we have, if we write it out like this, 1/3 p to the 5th, is all of the symbol pushing that we have. It's based upon the idea of a number on the top, a number on the bottom. So my question for you is, if I got 1/3 p to the 5th, where does that p to the 5th go? Does it go to the top? Does it go to the bottom? It would have to go to the top. So by writing the answer as, no, it wouldn't be. P to the 5th over 3 is easier to work with when we move on to the next steps. See what you're looking, you're just looking at how to simplify it. If we would have to multiply, I can't multiply this. I can multiply this. I would have to change this into that form in order to do it. So, I'm going to give you a minute here, and I want you to play with the next one. So close. Yeah. You like the bell? I got new software, new program. So, I've got an A. I said I have an A over 6a to the 4th. So this a cancels with one of these down here, and I have 3. Now, we are always doing the operation of division for this, for those who are paying attention. When I divide something by itself, what number do you get? 1. Okay? So if I take a divided by a, I am left with a 1. If I have nothing else left over there, I got to have that 1 thing. Now the 6 is still down here, correct? And a cubed. Okay? Because there's an a on top, 1 a on the bottom. Okay? Yep, so you got to cancel 1 off the top, 1 on the bottom. Yes. because 6a cubed is a completely different thing. You have to remember that I can take any number I want and put it over 1. So is this the same as this? No. Think about it. If I have 2 and I have 1/2, are those values the same? Can I put 2 over 1 if I want to? So, are those equal? No. That is why we have to make sure that we write that 1 on top to keep the denominator and numerator. We have to make sure that we separate out denominator and numerator. Now, the only way that you could get by writing this without a fraction would be, and actually, no, you can't do it because you got that 6 in the denominator. You can't go and, you could move the a to the top and have it a to the negative 3, but we wouldn't do that. So, let's give this a try. Do C. All right. So, first thing that I see is in the numerator, I have an x and an x in each one of these things. It's the only thing that I see in common. So if I factor out an x, I am left with x plus 7. Does that track for you guys? X times x is x squared. X times 7 is 7x. So there was x in each one of them, so I factored that out. I pulled it out. Now, let's take a look at the denominator. Is there anything in common with the denominator? Well, I can't pull the x's out, but I see that I have 6 and 42. Is 42 divisible by 6? Yes. So if I factor out a 6, I am left with x plus 7. So now that I've got that, I've got x and my x plus 7, 6 and x plus 7. Can I cancel this one here with that one down there? Yeah, same thing on top, same thing in the bottom, as long as it's multiplication. And my answer for this one turns out to be x over 6. And now when I say that, write yours down, see what you got. Write mine down next to it so that you've got a correct solution. That way you can see the difference as to what it is that you were supposed to do. This is kind of like learning the hard way, but it is learning. So, let me give you another 2 minutes, and I want you to take care of the next problem. Alrighty, here we go. Now I look on top here and I see I got a 2 and a 2 and I got a 10 and a 10. I also see some signage problems. This term happens to be negative up here. This one down here happens to be positive. So I'm kind of thinking that I might want to go and take that out. But I'm also looking at this, that this is a x squared plus 2. And gee, if this was a minus in here and a 1, that would really help out, because then I would have difference of squares. So for the numerator, I am going to pull out a negative 2 and see what's left. What's left? X squared minus 1. On the bottom, I am just going to pull out a 10. So I pull out a 10 and I'm left with x minus 1. I can't cancel yet, because that numerator is a difference of 2 squares, and yes, you take the square root of 1 and you get 1. So this is going to factor out one more time as negative 2, x plus 1, x minus 1. Remember, difference of squares. And I get a 10, and I've got an x minus 1. Now, do I have anything that can be canceled? Yes. And so this x minus 1 here cancels with this x minus 1 here. Gone. This 10 cancels with the 2, and I end up with a 1 up here and a 5. Now, Yes. Yeah. I'm not worried about the sign yet. I'm just worried about the values. So I am going to look at this and I see that I got a -1 and I've got this thing out here. I'm going to write it as this: negative x plus 1 over 5. Now, if I wanted to, yeah, I could write it as, you would also see this answer listed as, let's see, well, negative x minus 1 over 5. That would be a possibility as well, if you distribute the negative around on it. Again, it all depends upon what you are shown.